Today we're going to talk about survival functions and how important do they have to be in order to be called survival functions. So our first survival function is called the constant. Now remember that you need to print out these notes and take the notes so that you can make a copy and send them back to me so that I know that you have taken the notes. So first of all, the constant function is f of x equals, let me get this out of my way here. My board is like my board here. Okay, f of x equals c. Of course, not working. So I'm going to get my pen working here, maybe. And this thing is as bad as my board, so we'll see if this works. So those of you that have been in my class know that sometimes it can be a little bit possessed. All right, so we're going to start with the constant function. So the constant function is f of x equals c. And in this case, c is a number, okay? Just any number. And let's say that, for instance, that c is 3. So remember, f of x means y equals. So if y equals c, then, and we say that y is 3, so this is 1, 2, 3. So there's our y equals 3. And so we just draw the line here at 3. And so we get a horizontal line. So a constant function will always give us a horizontal line. Now, the x-intercept of this graph, well, does it cross the x-axis? No, it doesn't. So there is no x-intercept. And the y-intercept will be whatever c is, okay? Now, remember, the domain is our x's of the graph, and the range is the y's of our graph. And we go from left to right or up, down to up. So the domain is from negative infinity all the way over here to positive infinity. And so we say this is negative infinity to infinity, and we do this interval, okay? And the range is the y values. Well, the only y value we have here is whatever c is. Increasing would be wherever the function is going up, and decreasing would be wherever the function is going down. Well, this function is not going up or down. It's just going straight across. So it is never increasing, and it is never decreasing. And because it doesn't do both of these, it cannot have a max or a min. Now remember, a max is where the graph flips over up here, and the min is where it flips over and it's down here. Now, the end behavior is what is the graph doing on its ends at the very end of the graph down here. So it says as x goes to infinity. So as x goes to infinity, then y goes to what? What does y go to? Well, y goes to c. And as x goes to negative infinity, what does y go to? Well, it still goes to c, okay? And that one's a little bit hard with some of these parts. So we're going to talk more about these parts as we go a little further, okay? So our next function is our linear function. So the linear function is f of x equals x. So what do we know about this? If the line is y equals x, well, it has a slope of 1 and a y-intercept of 0. So if we were graphing that line, we could start at 0 and go up 1 over 1, and we would get this line. It would be straighter, but it would be like this, okay? So the x-intercept, where does it cross the x-axis? Well, it crosses the x-axis right there, right? So that's at 0. Where does it cross the y-axis? Well, it crosses right there. That's 0. So the domain is how far to the left does this graph go? Well, the graph goes all the way to negative infinity. And how far to the right does the graph go? It goes to negative infinity. So left to right, we get negative infinity to infinity. And the range is how far down does the graph go? Well, that's negative infinity. And how far up, see there's the arrow, does the graph go? Well, that's positive infinity. So down to up, not up to down, but down to up, because it has to be in order. So negative infinity to infinity. So where is it increasing? Well, we always go from left to right, and we always use the x's with parentheses, okay? So if we use the x's with parentheses, where's this graph increasing? Well, it's always increasing, always. So from negative infinity to infinity. And so it's never decreasing. Some will say, oh, what is decreasing over here? No, it's not, because it's going up from left to right. And because we don't have a going down part, it doesn't have a max and it doesn't have a min. Okay? Its end behavior is what does it do on the ends? Remember, that's all it's asking me. As x goes to infinity, so as x goes this way, what does y do? Well, y goes this way. Well, what is that? It goes to infinity. As x goes to negative infinity, so as x goes this way, what does y do? Well, y goes this way. Well, that's negative infinity too. Okay? And so that's all there is. All right? So the square term, or the quadratic term, it's really called the quadratic, and we call it the square term because it's x squared. And remember, x squared makes that funky shape we call a parabola, not a parabola, but a parabola. And for the rest of these graphs, they won't be exact. The squares in the back really don't matter. I could have just drawn the xy axis because I only care about the shapes at this point. So it would go through the origin and it would make this U shape. Remember, the quadratic parabola is a U shape and it goes through this. So the x-intercept is 0. The y-intercept is 0. The domain, it goes how far to the left? To negative infinity. How far to the right? To positive infinity. So negative infinity to infinity. The range is how far down does it go? Well, it goes down to 0. And how far up does it go? Well, the arrows say to keep going to up here, which is positive infinity. Now, when we're writing notation for domain and range, we want to include this 0. So anytime we include that number, we put a bracket on it. Parentheses don't have, infinities don't get brackets because those are a concept. They're not a number, so we can't include infinity. It's just a concept. So where is the graph increasing? Well, the graph's increasing on this side. So it increases from 0 to infinity, and it decreases over here from, now you got to put it in order from the number line, from negative infinity to 0. We would not say 0 to negative infinity. Now, we can't include 0 because that 0 is it increasing or decreasing? Well, it's not doing either one. It's flipping over. So that's why they get parentheses here. Okay? Now, does it have a max? It does not. But it does have a min. So its min is at 0, 0. Its end behavior. So as x approaches infinity, what does the graph do? Well, the y value goes to infinity. And as x approaches negative infinity, what does the y do? Well, it also still goes to infinity. So we write that it goes to infinity. The cube, or the cubic function, is just that. That's x cubed. Okay, maybe it won't write. Come on. I had this problem before. I think this thing is as possessed as my board. Those of you that have been in my class know that my board's possessed, so I think this, who knows? Okay, so the cubic function is x cubed. This is not the walks like an Egyptian graph. The graphs they don't curl out. They should curl in on themselves. They're kind of like a quadratic graph. You get a half over here and then a half over here. Helps if I could draw a little bit. I'm going to erase some of this. There we go. And so our graph looks like this, x cubed. So the x-intercept of this graph is right here. It's at 0. The y-intercept is 0. The domain of this graph, the graph goes this way all the way to negative infinity, and the graph goes this way all the way to infinity. Even though it looks like it stops right here, it's gonna keep going this way. So we say negative infinity to infinity. And the range of this graph goes all the way down here according to this arrow, negative infinity. Oops, I don't know why I drew that. To positive infinity up here. And increasing, well, if we go from left to right, this graph is always, 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 always increasing. So we go from negative infinity to infinity, and it's never decreasing. And because we have no decreasing, we have no max and no min. The end behavior of this graph, as x goes to infinity, what does this graph do? What does the y value do? It goes to positive infinity. And as x goes to negative infinity, what does the y value do? Well, it goes to negative infinity. And so we do that. The square root graph is exactly what it says. It is the square root of x. I call it the swoop graph. So it starts right here at 0 and it swoops over. Its x-intercept is 0. Its y-intercept is 0. Its domain starts at 0 and includes 0 because you can take the square root of 0. And it goes all the way to infinity. And the same thing, it starts down here at 0 and it goes up here to infinity. Even though it doesn't look like it's really going to get there, it does. So again, we start at 0 and we go to infinity. This graph is always increasing, so from 0 to infinity, and it's not increasing or decreasing at 0, and it's never decreasing. Now, this is the one case where you can have no decreasing and have a max or a mid. It doesn't have a max, but this graph definitely has a min. It has a min at 0, 0. Okay? Then its end behavior here, as x goes to infinity, the graph will go to infinity, and x doesn't go to negative infinity. It doesn't go this way. And so this doesn't apply here. Okay? The exponential graph is f of x equals b to the x. And it's called the exponential because x is in the exponent. X in the exponent. And b is a number, usually e. And y'all haven't really talked about E, but we will talk about E in this class. And so the graph goes real close to the x-axis right here, real close. And then at 1, it goes through 1, and then it swoops up real quick. Okay? So its x-intercept, it has no x-intercept. Oh, not 0. It has no x-intercept. And its y-intercept is at 1. It has no x-intercept because the x-axis is an asymptote. The x-axis is an asymptote. And what that means is that graph gets closer and closer and closer to the x-axis, but never really touches it, okay? And so the domain of this graph goes from negative infinity to infinity. And the range of this graph goes from, it starts way down here at 0, but it doesn't include 0 because remember we just said that it doesn't cross the x-axis here. And it goes up here to infinity. It is always increasing from 0 to infinity. From negative infinity to infinity because it goes from x to x. Hello. And it's never decreasing. Its max is none, and its min is none. Its end behavior, what does it do on the ends? Well, as x goes to infinity, what does it do? It goes to positive infinity. And as x goes to negative infinity, what does this go to? Well, it gets right up against this asymptote. It gets closer and closer and closer to this asymptote, never touches it, so it goes to 0. Okay? Absolute value. We're almost done. So f of x equals absolute value of x. And so absolute value of x is absolute value of x. So this is the v graph. I think about v like absolute value. And so it goes, and these lines should be straight, obviously. But, I can't draw a straight line. It's so sad. So the x-intercept is here at 0. The y-intercept there is 0. The domain is negative infinity to infinity. And the range is from 0 to infinity. And we include 0 because we can take the absolute value of 0. It's increasing. Remember, that's this on this side. So from 0 to infinity. And it's decreasing over here on this side. And so we say that's from negative infinity to 0. Remember, put them in order. Has to be in number line order. It doesn't have a max, but it does have a min at 0, 0. And its end behavior, as x goes to infinity, y goes to infinity. And as x goes to negative infinity, y goes to negative infinity. No, positive infinity, I lied. So that's the survival functions. So after you take the notes, make sure that you take a copy of them, and so that you'll have them along with your transformation notes. You'll watch that video and take the transformation notes, and make sure to do your family of functions activity in your PowerPoint slides. That's it for today.